Welcome back to the All About RFID series. I'm Kyle Stanford, your RFID solutions architect here at RedBeam, and we are here today to talk about read range and what affects RFID performance. I'm not going to lie to you, I usually have a board behind you. It's pretty much filled up with things I need to cover. On this one, I have like 5 bullet points, and that's it. So I'm going to do a lot of talking. I don't know how long this video is going to go, but if you were counting on me to fix your RFID situation that you're in right now, I may not do that, but I may be able to spur some ideas in your head of what could be affecting your situation, right? So the spoiler to this is that everything can affect your RFID performance. Down to the relative humidity in the air can actually affect read range. Not drastically, but it can. So read range defined max distance where communication can take place between a tag and a reader. Maybe this far, maybe 30 feet, right? If you are having trouble in either direction, right, read range is not always a problem of trying to get further read range. Sometimes it's trying to reduce that where you're not reading tags you don't want to read, especially in fixed reader deployments where we're trying to just read a specific area. Or even in a mobile reader where you're trying to maybe only read one box and not the box next to it, right? So read range is affected by signal strength, environment, design, the physics, right, of the environment. But there's really 5 big factors that we're going to talk about. So the tag, essentially larger is almost always going to equal further read range. That is just the simple fact. If there's more antenna surface area to absorb energy, you're going to be able to talk to this tag further away. Yes, there are some tags that perform better than others. Typically, they're within the same size range though, right? So your tag has to be selected in such a way, we've talked about these in another video, that is going to work in your environment for what you are trying to do. That may mean you don't need a big tag because you're right on top of the tag with a mobile device all the time. It may mean that you need a giant tag because it's on a dozer as it goes through a portal and your antenna is 15 feet away from the tag. So tag selection, very important. Power settings on the reader. It sounds so simple, but it is often so messed up. If you are trying to read a very large area, then you need your power settings up. But if you are trying to read just one box and not the tags next to it, you need to drastically reduce those settings, right? These settings are in different things. In the RedBeam software, it's 1 to 100%. We'll keep it simple. In the actual settings of the device, it could be 10 dBm to 30 dBm, and that is not a linear line, right? dBm is logarithmic, so it's going to do a cool little, yep, there you go. There's your chart. You got it. So that's dBm. So where 50% is not 50% power. So you have to think about that when doing your power settings. Make sure they're correct for the situation. I often generally know where to start. Maybe it's around 65% power, and we end the project at 73% power. It's getting there close, and then just finite adjustments from there to get the read range perfect, where you're reading what you want to, but not reading what you don't want to. That is greatly affected by your antenna gain and type. Again, all of these things are things from the previous videos. We just talked about antennas. Your antenna gain and the type of antenna is going to affect your read range, right? So your tag orientation is going to be affected by the antenna type. Is it linear or circular? Are you trying to read it on the horizontal plane like this with a linear antenna? You're going to have a problem. So environment and materials. Again, we talked about environment. We talked about materials earlier too. Are you trying to read metal with a non-on-metal tag? You're going to have a bad day trying to read that big giant metal device when you put a tiny little non-on-metal tag on it. Your environment around you. One thing I really haven't talked about up to this point is interference. Because the 900 megahertz spectrum is an unlicensed spectrum, people are allowed to deploy things in it. There are still projects that we have had to walk away from because they would not give up their cordless phone system. And every time they walked under an RFID antenna, they got static on their phone, and we had to double the power to make it work the way we wanted to. So they just didn't work nice together. There was interference in the area. So there are handheld spectrum analyzers that you can use. I take one on every survey I do and just carry it around and make sure there's nothing crazy. You never know when this stuff's going to pop up. Really old security cameras, cordless phones, weird stuff out there uses 900 megahertz still. So in lieu of reading bullet points for the rest of the time, I think I'm just going to go over some situations that I've been in and ways in which I fixed it. I'll start with a recent one. This was probably only 2 years ago. We went into this I'm not going to talk about the customer or anything like that. I'm just going to talk about the materials. So they had their material, and we were putting the tag inside of it. I underestimated how transparent that material was because it had no water content, no metallic content, and the RF essentially passed through it like it wasn't even there. So we used a decent tag. The customer actually provided the tag. It was a decent tag, but I used big linear handheld reader and big circular high gain antennas on the conveyors. This resulted in me sometimes, even at very low powers, reading tags that were 40 feet away that I didn't want to because of the reflection off of the metal conveyors. It resulted in the people trying to use the handhelds reading, again, tags 20, 30 feet away when they were trying to only read about 4 or 5 feet in front of them. Since transitioning them to circular antennas at lower power, may even transition them to some of the embedded readers that Balvina showed in the other video that only have like 4 to 6 foot of read range. So this was the opposite problem that you might be thinking. I had too much read range. I deployed all the best equipment, high gain antennas, thinking that I was going to have trouble reading through this material. So it's one situation. Linear when using circular was also within that same deployment. One of the other issues we have is simply stated software issues, whether it be firmware on the reader needed updated, firmware on the device needed updated, firmware on the sled needed updated, our software needed updated. We get ourselves into issues where we are looking at the physics and focusing on that and not realizing that the software is working against us sometimes. We've gone through issues of troubleshooting end-to-end with a customer for days on site, only to figure out that we were actually sending the data from our software to them, and their software was not accepting it because they only accepted so many calls per minute. So focusing on every little piece of the pie along the way and doing that end-to-end troubleshooting is key in making the actual project work. And then a fun one, which is walls of paper. So certain retailers will stack up all of their paper, reams of paper, and make a wall of paper in their warehouse. That wall of paper might as well be a 6-inch steel wall. We can't get any kind of RF. They were having Wi-Fi issues behind the wall of paper. We couldn't shoot RFID through it. Bluetooth, you couldn't even sync with a sled on the other side of this wall of paper. It was a steel wall that did not, it not only didn't reflect it like steel, but it literally absorbed it. Just a wall of paper reams. I think you got a picture. There you go. So what can affect your RFID performance? Everything. Everything and anything. Start from the beginning. Start at the simplest stuff. Make sure your reader's powered on, your software is up to date, that the reader's actually getting reads from test tags. Start there. Work your way into all the little pieces. Did I choose the wrong antenna? Did I choose the wrong tag? Did I choose the wrong reader? Did I choose the wrong type of antenna? The wrong polarization? Is my tag orientated differently? We've walked into ones where they were supposed to be just presented like this on the conveyor the whole time, and we get there and they were actually folded over and turned sideways. So of course we're going to have more trouble reading them and use more power to do it. So yeah, go through everything you can, take all the little steps. Troubleshooting an RFID project can suck. It feels like magic because you can't see the RF waves flying through the air and flying back from the tag. But you have to use a little bit of scientific technique and go through it step by step and troubleshoot the process. All right, that was interesting and different. But next up, we're going to do RFID myths and misconceptions. This one should be fun. This is one that I only put in here because we've had to deal with it over the years. I went on a lot of sites and had to deal with different users with their myths and misconceptions. And I'll tell some stories about that. So stick around.